Hey everyone, huge congratulations on officially conquering Chapter 2. You know, it's super common to read a chapter and then completely blank on it right before the exam. That's exactly why a solid revision is absolutely crucial. It helps lock those concepts in for the long haul and massively boost your confidence. So let's dive right into this explainer to revise everything step by step and get you 100% exam ready.
Okay, let's take a quick look at our roadmap for this revision explainer. We're going to cover core concepts and indicators, crucial chemical reactions, the pH scale and salts, tackle some high-yield exam questions, and finish up with a final review of key formula.
All right, let's jump right into Section 1, Core Concepts and Indicators.
So think of acids and bases as total chemical opposites. Acids, like the lemon juice in your fridge or hydrochloric acid, are the ones producing hydrogen ions when you dissolve them in water. They've got that classic sour taste, and remember, they turn blue litmus paper red. On the flip side, we have bases, like sodium hydroxide. These guys produce hydroxide ions in water. They're bitter, they feel kind of slippery to the touch, and they turn red litmus paper blue. Getting these basic physical and chemical differences locked down is basically your foundation for this whole topic.
Now, what's really cool is how we can identify these without having to taste or touch them, which, by the way, you should definitely never do in a lab. We use chemical indicators. Take a mental snapshot of this. Notice how turmeric doesn't change color in an acid, but it turns this reddish-brown color in a base. Or phenolphthalein. It is completely colorless if it's in an acid, but it pops into a bright pink in a base. You're going to want to memorize these exact color shifts for your exams for sure.
Moving right along to Section 2, Crucial Chemical Reactions.
Okay, if there's one thing you take away here, it's mastering these 3 big reaction rules. First up, whenever a metal reacts with an acid, it's going to yield a salt and release hydrogen gas. Second, if you mix a metal carbonate with an acid, you get a salt, water, and carbon dioxide. And the third one, which is literally the star of the show, is when you combine an acid with a base. They completely cancel each other's properties out to form salt and water. We call this highly specific reaction neutralization.
To put that first rule into perspective, check out this exact chemical equation for zinc combining with hydrochloric acid. When solid zinc, our metal, reacts with the acid, it forms zinc chloride, which is our salt, and actively bubbles off hydrogen gas. Being able to confidently write and balance this specific equation is an absolute must-have skill for your test.
Next up is Section 3, the pH scale and salts.
So, on the pH scale, which is just how we measure acidity and basicity, the number 7 is the magic middle ground. It represents a perfectly neutral substance, like pure drinking water. Anything under 7, that's acidic, like your lemon juice. Anything over 7, that's basic, kind of like a slippery soap solution.
But here's a number you really need to pay close attention to, 5.5. Because when the pH in your mouth drops below this specific acidic threshold, usually thanks to bacteria, that is exactly when dangerous tooth decay starts eating away at your enamel. It really proves that the pH scale isn't just textbook theory. It's literally happening in our bodies right now.
Actually, pH plays a massive role in everyday life. In your stomach right now, hydrochloric acid is helping digest your food. Out in the fields, farmers are constantly testing soil pH to guarantee healthy crops, sometimes even tossing in lime to dial back the acidity. And get this, if you ever get a bee sting, the venom is actually acidic, so applying a mild base, like baking soda, neutralizes it and totally takes the sting out. Pretty cool, right?
Now going back to when we neutralize acids and bases, remember we said it creates salts. Well, these aren't just random chemical byproducts, they are super useful everyday compounds. We're talking about the common salt you sprinkle on your fries, the baking soda used to bake a cake, washing soda for laundry, plus bleaching powder and even plaster of Paris, which is used for medical casts and building construction. They are everywhere.
All right, let's get into the real meat of this explainer in Section 4, high-yield exam questions.
Let's kick off this rapid-fire challenge with a couple of short-answer questions you'll probably see. First, how would you briefly and accurately define neutralization? And for a 2-mark question, why exactly do acids conduct electricity when they're in a solution? Take a second to lock in your answers.
Okay, here are the precise answers straight from our core concepts. Neutralization is simply the reaction between an acid and a base that produces salt and water. And as for the electricity question, it's all about those free-floating hydrogen ions that acids produce in water. Those ions are exactly what carry the electric current straight through the solution.
Stepping it up to a classic 3-mark question. How would you quickly explain the zinc reaction? And list out the key indicators. Examiners absolutely love combining concepts like reactions and indicators into a single question like this.
And here is your golden answer key. You just write out that perfectly balanced equation. Zinc plus 2HCl yields zinc chloride and hydrogen gas. Then you just list those 4 primary indicators we talked about: litmus, turmeric, phenolphthalein, and methyl orange. Nail both of those parts, and boom, you secured all 3 marks.
Now for the big one, a 5-mark question. Explain the importance of pH in everyday life. For this one, the examiners really want to see you synthesize the big picture. It requires a multi-point answer spanning biology, agriculture, and daily living.
To get full marks, you've got to list these 5 real-world impacts. You want to mention how it helps digestion, how a pH below 5.5 causes tooth decay, how it maintains blood balance in the body, how it helps farmers manage agricultural soil, and finally, how it protects sensitive aquatic life in our rivers and oceans. Hitting all 5 shows you totally grasp how crucial pH is for living organisms and the environment.
Almost at the finish line. Section 5, Final Review and Formulae.
Okay, knowing these exact chemical formulae is absolutely non-negotiable for passing your exam. Make sure you know hydrochloric acid is HCl, sulfuric acid is H2SO4, and sodium hydroxide is NaOH. And whatever you do, do not forget the salts. Common salt is NaCl, baking soda is NaHCO3, and pay extra special attention to plaster of Paris, which is CaSO4.5H2O. Seriously, take a mental screenshot of this right now.
Before you pack up your books, let's lock these 5 final summary points permanently into your brain. 1. Acids release H+ ions. 2. Bases release OH- ions. 3. The pH scale simply tells us acidity or basicity. 4. Neutralization is always acid plus base equals salt plus water. And 5. Those salts have countless practical uses every single day.
So I'm curious, which topic in Chapter 2 did you actually find the most interesting? Was it the sour bite of acids, the slippery nature of bases, the super relatable pH scale, or all the everyday uses for salts? Drop your answer in the comments below. And hey, be sure to join me next time as we dive into Chapter 3, exploring the fascinating world of metals, nonmetals, their properties, and some really cool reactions. Until then, keep studying hard, you've got this.